Let's Make It is brought to you by Ting, the new way everyone is getting their cell service. No overage penalties, great rates, keep what you do not use, no contracts, and someone will actually pick up the phone when you need support. Use our link and get $25 off your first month's service or your new phone. Just go to tech-zen.tv/ting to save $25. Hello, it is Monday night at 9 p.m. and it is time for another Let's Make It. So we record Let's Make It every Monday night at 9 p.m. Eastern Time. That would be 6 p.m. on the West Coast, and I'm not quite sure, maybe midnight or something like that in UTC. I'll have to go figure that out, I guess. Anyways, it's 9 p.m. and we're actually not quite 9 p.m. We're like 20 minutes early this week because we have something going on here in a little bit that we need to be done for. So we're starting just 20 minutes early. So if you missed us and you weren't in the chat room early and chat with us beforehand, sorry, but we just have a little bit of a change this week. This is episode 37 of Let's Make It, recorded on 9/23, that is September 23rd of 2013. And Let's Make It is a show where we talk about all kinds of fun things to make, typically in the electronics realm, a lot of Arduino, other type of electronic things like that. But this is the show where we talk about it. And normally I have a co-host, Bob, from Texas, on with me. But tonight, I'm going solo. But tonight I have something kind of special. But before I get into the special thing tonight, I do want to talk about one other thing. So I'm going to hop into that in a second. But first of all, if you want to watch our shows, you can watch them all on our YouTube channel at youtube.com/techzentv. Love to have you go out there, hit the subscribe button. That definitely helps us out. All of our videos are in playlist format, all different shows, so you can follow a show from beginning to end without any other interruptions. Or if you want to watch other shows that we have, I'm sure you like some of them too, you can definitely watch them as well. And if you're on Twitter, you can contact us on Twitter, direct message us, whatever. And our Twitter handle is @TechZenTV. And if you're talking about this show, make sure you include the hashtag #Let's Make It. We do monitor those hashtags so we can see where people are talking about us and our show. When we love to see that out there, it definitely is a little bit of a boost to us when we see people out there talking. And if you're on Facebook, you can go to our Facebook fan page. It's facebook.com/TechZenTV. Definitely appreciate if you hop out there and click the like button. It gives us a little bit of a boost as well. And lastly, you can get all of our show notes and watch all the other episodes of this show and all of our other shows by going to TechZenTV. Now, if you want a little bit of a trick, the shortcut to get directly to Let's Make It is if you go to letsmakeit.tv, we take you right to the right place in the site, so you don't have to go through the site. You can navigate through there. Also, if you are downloading us via like iTunes or some like Dogcatcher or any of the other popular podcasting platforms out there, be sure you go out there and you give us a rating and a like, because that definitely helps us get found, particularly in iTunes. We're really trying to get found in iTunes right now, and anything you can do to help us get up there. And unfortunately with iTunes, unless you've been found, they won't help people find you, it seems like. So it requires you to have a good rating and ratings and comments for people to get found out there, to get more of those. So unless you're popular, you don't get popular. It's one of those type of things. So anything you can do to help us get a little bit of a better boost out there in iTunes, give us a little bit of rating, definitely gives us a big jump up. If you got a Roku or a TiVo, you can actually watch us on your big screen right from the Roku or the TiVo. We have a Roku app for TechZen TV. You can go out there and you can get that, and you can watch all the shows, including this one there. And on TiVo, you can get a season pass, and you get regular updates when new shows come out, all completely automatically. And there's all kinds of other ways you can get us. We're pretty much everywhere, or we're on every podcast directory you can think of. We're in TuneIn Radio, on Stitcher, you name it, we're probably there. And if we're not, let us know. We will get there, because we want to be everywhere that's possible to be found. All right, so before I go into the special thing I'm going to do tonight, because you're not going to be interacting with me a lot because there's something special coming up, but I do want to show you something else. So I've been pondering this, and basically a little bit of background is I was asked by my brother and sister-in-law about maybe getting my nephew into doing some basic programming. And we talked about a couple different options, and they have some options that they like to do, and I do agree that that's what they were looking to do. But I got thinking about it. How would you teach a young person about electronics, Arduinos, and programming? So I started looking around, and what I found was this book, the Arduino Adventures, and it's actually a story, and it's actually Arduino Adventures Escape from Gemini Station. In this, the story is generally two kids that are on like a class field trip get broken out from the rest of the group, and they get into this area. It's called Gemini Station. It's kind of like if you're going to the museum and you get in an area where the museum takes you somewhere, and like in history, I can't think of a good example, where you get sent into another time. And it's kind of what Gemini Station is they get stuck in this station, and they got to build these projects to get like to unlock things and to look for heat and things like that. So it's very interesting. It's a story, but at the end of each chapter of the story, there's things they have to learn. So this is the book right here. It's James Floyd Kelly and Harold Timmis, I guess how you say it. Timmis, Timmis. And let me go through real quick here, and I want to read. I can give you a couple of the things they do in here. So let's see. Here's the parts list, for example. You learn how a potentiometer works. There's an LED flashlight, a temperature detector, a motor control, a motion detector, a servo motor control, light sensing motor control, and then build your own robot. And they do actually have you build a robot at the end of this. So this is all, they learn how to do all this stuff through the book, through doing these challenges at the end of each chapter. And some of the chapters are like the Hulk. Let's see. Carousel ride. Let's see. Hide and seek. I'm going back through uninvited guest, damage assessment. So there's always these are the different chapters that they do. Anyways, it's a really good book, and it teaches basic stuff. It doesn't go into a lot of electronic theory. In fact, it goes into no electronic theory. It is basically tells you how to hook it up and then and understand the programming behind it. So it doesn't teach like Ohm's law or anything like that. It's a completely separate subject. However, it does have, and I found when I got the book, they're selling a kit. Now, what I found out later on the kit wasn't part of the book. It wasn't the same people. But I'm going to go show you the kit. And in hindsight, I probably shouldn't have done it, and I'll explain why when I go through it. But let me do the first part of the kit here. Let me put the book down over here. And let me go back to this. So this is I said about they make a robot. So this is a robot kit, for lack of a better word. If you may be familiar with the name. In fact, if you go look it up on Google, or you go to Amazon and look it up, it's the Magician chassis, and it basically is a robot. You can see there it has the chassis, has 2 tires, 2 motors, a bunch of standoffs to connect everything together, and you'll see also where to go. Oh yeah, there it is. It's not really a caster per se, but it's like a round ball and a metal thing. It basically goes any direction. So you basically steer by using 2 wheels, and then this wheel goes any direction. So you can go forward in one and back on the other, turn things like that. But anyways, that's part of the kit that I was included. Now this kit was like $70 or $80. It was a little expensive for everything that's in it. This you can get off of Amazon for like $24 or something like that. I have another one of these, and I'm actually going to use it for all my upcoming episodes about building robots. So, but let me show you everything else that came in the kit, and some things I like and some things I don't like about it. So this is the kit right here, and I'm going to open it up here and go through each thing individually. You can see off the top right there that there are 2 breadboards. Actually, there's 3. So these are clear breadboards. I don't really care what color breadboard's a breadboard to me. So there's 2 clear breadboards, and there's another one in here somewhere I'll get to. It's a lot smaller. It's like the ones we sell, kind of. All right, so we're gonna go through the list here. Here is a pack of 5 green LEDs, 5mm LEDs. Here is a trim pot. I don't know if you can see in there the blue trim pot, same one that we use. Again, it's like a few 30 cents maybe, something like that for one of those. So we're up to maybe $3 worth of parts so far. All right, here's the part a little confusing to me. They give you this battery thing. This is 4 AA's, but it's square. I'm gonna save this for a second. All right, so we have this infrared sensor or motion sensor. We did an episode on motion sensors. Those are a couple bucks. So we have the 10mm LED. We have a buzzer. We have a DC motor. We have these terminal connectors, which you know, I had those in inventory. I could have pulled those out of inventory. Actually, most of the stuff so far I actually have in inventory. I could have pulled out, except for maybe the motion sensor. All right, here's the other breadboard. It's the same ones that we sell on our development kit board, where this is attached to the development kit board. I'm not quite sure what the third one's for. All right, so we have a 100 ohm resistor. There's 10 of those in there. So there's a 60 cents or more. All right, so last week we talked about the H293D H bridge. There's one of those. That's doing use for motor control right there. Here's the other battery, flat 4 away. I'm not quite sure the reasoning behind the flat 4 versus the square 4, but whatever. Okay, so we're gonna keep on going here. We have a 9-volt battery connector. We have the all-famous 10K all-purpose resistor. There's 10 of those in there. We have the little jumper. There's about 6 cents right there. The bag probably costs more than that. What's this one? Temperature sensor. This is the common... oh, no, it's not quite so common. This is the TMP36, which I'm not quite sure what that is. Isn't the TI, popular TI chip, but it probably works exactly the same. We have another 9-volt battery connector. Again, not sure exactly why. We have, looks like 5 buttons, push buttons, which I'll have a few hundred of those sit down in a bin out here. And let's see, we got 5mm red LEDs, 5 of those. We have a servo, a very tiny servo. I am not quite sure if it does any function or just for learning, but those are rather inexpensive as well. Okay, and let's keep on going here. I'll save that one. So we have 330 ohm resistors, probably for the LEDs, which is more than needed for that. I mean, 270s work really good, but they work fine. We have another chip here, SN74F04, which I haven't gone and looked it up and seen what it is. I'm guessing it's some kind of opto isolator or isolator, probably for the motor controller. Let's see, we have, what's the header? Stackable header. So basically it's long pins with holes on top. Then we have, let's see, we have a photo cell. So we're getting down there finally. We have jumper cables, like we have, you know, thousands of in the other room, in bags ready to be sold. We have a USB cable right there. And the reason for the USB cable is this, which is one of my biggest complaints about this whole thing. It comes with this Arduino, this tiny, tiny little Arduino. It is a Smart Core U. So you can see it's tiny. The thing is, to be able to work with anything jumper-wise, you need to add this to it. So you can see on this in here, you see the white plugs. And if you look at this, you see the white plugs on the back. So you attach this board to this board to make an Arduino. Well, that to me means trouble. Connections that could come off and not be tightly integrated, and you never know it, and you gotta attach something to this to get to work. I think I'm just going to send them an Arduino Uno. In addition, I'll probably give them this stuff too, but the Arduino Uno, and just tell them to use it versus using the small thing in this, because that just to me seems like a possible problem somewhere. So anyways, that was the kit that I bought. So my whole thing with is after I got it and I saw what was in it, and actually it does tell you in the back of the book everything you need, but I didn't have the book at the time. I just saw the kit goes with the book. So I bought them together when I got them on Amazon. So I got, you know, both of them together. However, it probably would cost half as much to just get the parts yourself. If you don't have access to all the parts, then yeah, maybe okay. But most of the parts that are in there we have for sale anyways, and I have them in inventory with a few exceptions to that. So in hindsight, I probably would have just gone and gotten the parts myself versus going and buying the kit. And I would have gotten a regular Arduino, not that tiny little thing that's going to be could be easily disconnected and misconnected and things like that. So anyways, it's a very cool idea. Teach a story and they'll be interested in it through the story and doing the projects. Like I said, it doesn't teach any electronics theory. At least not that I can remember, because I read the book. I read it fairly quickly, but it does teach the Arduino. It pretty much tells you connect it like this and put this code in, and it gives you some teaching around the Arduino itself, but doesn't go much into the actual electronic theory at all. All right, so that is it for that segment. So I do just want to remind everybody that we do this show live at 9 p.m. every Monday, and you can come into the chat room and chat with us. We're a little bit early today. We're still 5 minutes away from our normal start time. We started like 20 minutes early, just because we have some other things that are going on and we need to get done a little bit early tonight. So, but the next segment, I've already pre-recorded it. So as you may have already heard, I have been doing some surface mount. I've been learning to surface mount solder because a lot of things I've been designing needed some very small parts to keep the size down. And it's the first time I've ever designed a board with surface mount. From the last couple of things that I've created, actually I've probably created close to 30 different boards now, and using surface mount type parts on it. But when I first started learning how to surface mount, I was reading all about it. And the first time I did it, I got the wrong solder. I'm going to show you that in this video as well. The solder you don't want to buy. And in fact, I still haven't figured out what the solder is even actually used for, because it never ever melted on how I'm trying to cook it. At least it only melted with a soldering iron. So I've gone through and I got the right solder from a place that sells the solder. But the solder is kind of expensive. It's like $60 a tube. However, I got 3 tubes. I've done probably close to 40 boards now, and I probably haven't used a quarter of the first tube yet. So it goes a long way because it takes very little. In fact, that's some of the first mistakes that I made was putting too much solder on these boards, thinking it needed the amount of solder. It takes very, very little solder to flow solder. So these videos that are coming up are going to show you my progression in this and how I'm doing it and some of the mistakes that I've made. And I'm going to come back. I'm going to talk a little bit more about it when the video is done. So let's go watch the video right now. Okay, so I want to give a little bit of a story here. I've recently started developing something that I needed to do some surface mount, and for a couple of reasons. I needed to save some space, and some of the things that one of the chips I wanted to use was only available in surface mount, which is the first I've ever had that happen. But I want to today show you how to surface mount. So what you're looking at right now is a table. This is an old kitchen table that we had in the kitchen in the old house, but in the new house it's just downstairs here in the big room downstairs. So what I'm going to first of all recommend is you need a flat surface to work on in a fairly large area, and I'll show you why here shortly, because it looks like a real mess. Actually, let me go ahead and I'll widen this out here and I'll show you the mess that exists here in doing this process. So you see the table, and if you look over here you see all these bins of parts and extension cord, because I keep blowing the breaker on the one right next to me with this thing, and you see the griddle, which is what I've been using recently for the griddle. However, if you look up here, you can see a toaster oven that I'm going to start doing some reflow, a toaster oven, and I'll do another video. But before I go into all this, I want to show you some of the things that I use to do this and some of the differences between surface mount and through hole, which is what most soldering is. Let me go back down here. So first of all, I'm going to show you some mistakes I made, because I made some pretty major mistakes, and hopefully I can help some of you maybe avoid some of the mistakes that I made. Let me get this kind of square back up again. Okay, so first of all, here's one of these surface mount boards, and this is one that I've ruined. So first of all, you'll notice that there are some through holes here, and these are for buttons. These are for broadcast buttons, NKK broadcast buttons. But over here you see all these little pads. These are actually, well, there's 2 resistors. These are chips and things like that. Now, this is not a good representation of how small it really is. I'm going to show you that here in a second. But with surface mount, you only need to use one side. So the advantage to that is, on the other side of the board, there's no hole. So you can put other things over here, other surface mount stuff, or if you got a button that, like in the case of these NKK buttons, they're fairly large and they got a big base on them, but there's nothing on the other side they're going to hit as far as a chip goes. So it's a great way of saving some space, doing one side to put more parts on the board, which ended up being I needed a really compact board, so that's why I've gone this way. And actually, I really like it, so I'm doing a lot more of this now, now that I've figured it out. But you see that right there on this bottom chip right here, if I can get the focus or not. See all that big blob of solder? When I put the solder on there, it wasn't that much solder. In fact, it was so little I thought it wasn't enough still. And you can see the mess that it made. Now you'll see in there a couple runs that are crooked and a couple runs that are missing. That's because when I got done with this, I needed to clean it up. And to clean it up, I was using solder wick. And the solder wick just ripped it right off. They're very, very thin because they're not through hole. There's only on one side, and the copper on the board is very thin. So you can ruin these boards very easily. This board is definitely ruined. And if you look at it a little bit farther, you can see, so we get the focus, a couple other places where I got these big chunks of solder. Right there, I started the whole way across. And it didn't look like enough solder. So one of the things I'm going to say is you don't hardly need any solder. So this was also a board that used the wrong kind of solder. So let me talk about that a little bit. So when I first started doing this, I went out to Amazon and said I wanted surface mount solder, or liquid solder. That's what this is right here. Came from Amazon. Came in a little syringe just like this. Everything I was reading online said it comes in a syringe. I thought, okay, that's probably the right stuff. I will tell you, this stuff does not melt unless you have a full-blown soldering iron on it. I sat on this griddle and I actually ruined parts trying to get it to melt. So much so that I actually went out thinking I was something wrong and bought this heat gun, which did solve the problem. However, it melted the board to get it so hot for the solder. So my only thinking is this is actually jewelry solder. Even though it said it was electronic solder, they probably didn't know what they were selling. So it does come in a syringe, and it comes refrigerated. So let me show you the real stuff here. Let me grab it here. And I'll put a link to where I got this, but this is how it really comes, and it's refrigerated. It needs to stay refrigerated. And it comes in a tube just like this. Now, one thing is it doesn't come with a tip. So when you order it, make sure you order a tip. And when I first got it, the one thing I didn't order, thinking it had a plunger attached, it was a plunger. I do have now gotten one. But I will tell you, a pen pushed in the back and held safely in your hand works fine. Now here's the plunger. And it goes in like that. It doesn't, I don't think it screws in. It doesn't screw in, there's no screws to screw it in, so it just pushes in the back. But you take your finger and you push. I have different tips. This is the smallest tip that I have, and if I could get a smaller one, I would probably get a smaller one. The other one I have is a little bit bigger. Not much though, they're pretty close. So I just looked at it right here. So you'll see I keep it in a bag, and the reason I keep this in a bag is because it is very toxic if you would ingest it or get it on your skin. I have gotten it on my skin, and you'll see I'm going to use my fingers to do this. I just make sure I wash my hands shortly after I get done to get it off. So, being that it's toxic, I'm going to use a griddle. Saying that means the griddle can no longer be used for food, ever. Because this is going to be on the griddle, and it's not good for people to eat. So, the reason you keep it refrigerated is because it lasts longer, and it comes in a box with the freezer packs around it and all bundled up. When it got here, it wasn't frozen or it wasn't cold, really cold anymore, but it was cool. So what you keep in the refrigerator will keep it standing up. And I got three of these syringes. I have probably done 50 boards now, and that's all I've used of this syringe. So it goes a long, long way. So I'll put a link to where I got the solder from. The company I got it from, they're great to work with. However, they're just a little bit slow in delivery. But that's fine. Just make sure you plan for that. So I'm going to show you the griddle option here shortly as well. But before we get into this, I'm actually going to put something together, and then I'm going to time lapse through it. But here's a difference in size. So this will give you an example. These chips are the same chips. This chip is actually wider than the board that I wanted right there. So this chip on there is the exact same chip, it's just a different format. So you can see how much space that saves right there. And I want to say how small some of these parts are. I mean, that chip, yes, is small, but I'm going to do one that hopefully you can see. Let me get the tweezers out here because I can't hold it with my fingers. I can put it on my finger maybe. But this is a capacitor. It's in here. You probably can't see it. It's actually right there. Right there. That little dot is the capacitor. I'm going to put it onto my finger. Hopefully it'll focus if I can get hold of it. Okay, so let me put it onto my finger. So there's my finger. So there, you can see it on my finger. That's how small some of these parts are that we work with. So I keep getting it. That's in focus. See how small it is. You can see my fingerprint. You know, it almost fits into my fingerprint. So some of them aren't that small, but let me give you another example. If you've done things with the resistor arrays before, or resistor networks. This is a resistor network. This is a 1, 2, 3, 4, 5, 6, 7, an 8-pin resistor network. So you see how big that is. Let me get one of these. And this stuff all comes in these strips like this. So you basically got to peel back the paper. If you had a pick and place machine, it would just do all this stuff for you. But I am the pick and place machine. All right, so that came out pretty easy. Okay. Grab this. So here's the difference in size of these two. Resistor network right there, and resistor network right, focus please, right there. So this and this are the same thing. So you can see how much space that saves. So that's the reason it's about for surface mounting. It is very interesting how it works. I've still been reading a lot online, and I'm definitely still learning, but I can definitely show you the things not to do. Like I said, I ruined this whole board, first of all, for the wrong solder and the amount of solder. And I'll show you the board. I'm going to put together a board, and so I'm going to time lapse through it. But I'll show you afterwards. You can barely tell the solder's on there is a tiny, tiny little dot. So a couple of tools. Because the thing's so tiny, you need a magnifying glass. So I ordered one of these off Amazon. I used to have one as a kid somewhere, but I sure couldn't find it. Doesn't have to be this fancy. I didn't know it was that fancy when I ordered it. But, however, I don't recommend this because it takes up your hand. So what I've actually gotten, and it works very well, is a headset like this that you wear on your head. Looks a little geeky, but this is adjustable. It has a light on. I didn't know how to light on. I don't want to use the light very much. But you can turn it back. You can turn the power back by dropping that down. And you can turn up the power on one eye by bringing that down in front. And I do use this one quite a bit when I'm looking and make sure that no solder jumps happen. So I do check every board out very closely because I want to make sure I don't turn it on and blow a chip if I got to jump across it. But this works very good. Like I said, it looks a little geeky, but works very well. Also, tweezers. Now, let me just say, I've learned a lesson on tweezers too. First of all, I used tweezers from the bathroom the first time, and they have this little rough thing in there, I guess, for grabbing onto hairs when you pull them out of your eyebrows, but they don't work well. Chips don't let go of it. These are very smooth on the end. You can see, I won't focus on it, but these are very smooth on the end. I'm just going to get the focus this way. There we go. So they're very tippy. And I got a couple different kinds of these. I also ended up getting some electronic ones, but they're plastic. And you see what happened to the end? I'm dealing with 400 degrees plus temperatures here, so it just melted the tip of the end. So don't get plastic ones. No lesson learned. And I'll put links to these because these are actually very good, very smooth, and they come with different. I have some in the other room too. They aren't quite so pointy that I use for doing some of this, but I also say it's important. They come with a little cover that goes on the end. This little tip. Not that I've ruined any yet, but I can see how these little tips could get ruined, and this little white thing goes on the end. Just helps protect them so they don't get bent. So things you're going to need. I have this. As a temperature, it's a laser temperature, because the griddle, I set it for a certain temperature, doesn't necessarily always meet the temperature, and also it doesn't heat evenly, which is a problem I'm going to talk about when I do this. And part of the reason I'm going to look at a reflow oven, making an oven out of an old oven that we don't use anymore. So I think that's pretty much it. And you're just going to see me go through and put solder down, and I'll show you after I get the solder down what it looks like, and then I'll put the parts on it, and you'll see what it looks like, and then we'll go through and we'll actually reflow it on the oven here. And one other thing before I get started here, it's good ventilation because this stuff is toxic, like I said. The griddle does get very hot. You'll see me sitting here kind of close to it, and I shouldn't do that. And I can always tell when I do it because I don't feel so good afterwards. Feel like I got a cough and stuff. So definitely want to make sure you have good ventilation. I have a fan in the other room that I use when I do this to help with that a little bit. Alright, let me get this out of the way. And we'll get started on the board. So you can see, very, very... So as you can see, very little solder. I mean, you can almost barely tell it's on there. If you can tell by turning it sideways, no, it doesn't work well. I don't have good lighting out here is the problem. Also, you'll notice I'm using my headlamp, which I said I don't use very often, but the sun's not out today, and I'm in front of a window, which normally it's out. I've been using it a lot when it's out, so I can see a lot better, but today I couldn't. So that's it for that. Now I'm going to start putting the parts on, which is a little bit more tedious process than that. You may have noticed my fingers are jump a little bit because it does take quite a bit of pressure, and holding the pressure like that, my thumbs just aren't up to that yet. So I'm going to start putting parts on now. Okay, so now you see me put it on the griddle, and the griddle's not on yet, obviously, because I'm touching it, but I move the griddle over closer to the edge of the table so you can see it. And also you can see the marks on the griddle. That's from solder. That's why you can't ever use the griddle again for cooking. But you was watching me put this on. You saw me miss putting solder on one of the spots. And I actually put it one place I wasn't going to put a part. But it won't hurt anything. And I'm getting ready to turn. I'm going to go ahead and plug this in. Now, the other thing I mentioned we should have around for tools is a paper towel, called paper towels. So first of all, the tip of that syringe does get a little gunky sometimes, so it's good to clean it off so you get a nice clean on there. But also things to sit it down on, like you notice I came back and got it. It's because it's sitting next to me, and I set it on paper towels so I didn't get it off the table. But it's also nice to be able, if you mess up with one of these, you just wipe it off and put it back on again. So I might have one of the chips that has a little bit too much on it, but it'd be a good example of what happens whenever it jumps. So I'm going to go ahead and plug in the griddle. I do unplug it every time just to be safe. And then I'm going to turn it on right now for about 250 degrees. Because if you look at reflow, they generally tell you to heat it up before you go up to that level. That allows everything to flow evenly. It does seem like it works a little bit nicer than just turning it the whole way up to 400, which this griddle's top temperature is 400. And it should be like 450 probably for a real good solder, but it does get hotter than 400, and that's why sometimes the heat gun just helps to augment that. So I will fast forward this through this section. Okay, so you just saw me check it, and it is time to go to full temperature. So let's go ahead and turn it all the way up to 400. Well, let me just say this griddle isn't maybe normal for a griddle, but it's not evenly heated. You may, if you can tell, I'll see if I can draw a line, but around this right here, I don't know how much of that you saw, but there's actually a mark on the griddle where I think the heating element itself is. So I have this sitting on top of the heating element directly. The other areas outside of that strip take a lot longer to get warm. So something that I've learned by using this griddle, and I can see on the griddle where it's hot. So. Okay, I'm going to try to zoom this in a little bit so you can start seeing a little bit what's going to happen. You're going to start seeing the solder change color. See if I sit still, if it focuses. So when it changes color, it's starting to set up, and it eventually turns silver, which is when it starts to flow. We'll leave it like that for a little while. See what's it at right now, temperature-wise. It's at 396, so it's still warming up. Not quite there yet. Okay, it's getting there. You can see it's starting to silver up. And I'm not sure where I'm zoomed in on, but sometimes if you watch this, you will see, alright, it's 417, so it's not quite the whole way up yet. Sometimes you'll see that the parts actually move because the surface temperature of the surface tension of the solder brings things back into line again. So I'm going to get a little closer here, and this actually gets very warm, so you got to be very careful not to burn yourself. It's a little closer than normal too, so I got to be a little extra careful. But I'm going to look here and see how things are looking without trying to burn myself. Good so far. Still not quite melted the whole way. getting very, very close. Actually, that chip looks like maybe it is done. This one over here is not quite done. Okay, let me check the temperature. And we're at 438, so probably not a minute yet, and then I'll go ahead and turn the griddle off, and we'll let it start cooling down. Okay, so we're almost there. I'm going to move one chip just slightly. It's very hard to do when it's hot like this, but otherwise I gotta heat it back up there. Oops, too far. That's part of the problem with doing it when it's so hot. It just moves so easy. So let me fix this. It's very weird because I don't have very much to. Actually, I'm going to move it to where I can get to it easier. I'll bring it back over the camera. Now I can work on it much easier. There we go. That one chip was just slightly crooked, so I'll make sure to move that one. That was good, and that was good. Okay, so here we are. So I'm going to go ahead and turn the griddle off because everything looks like it's flowed good, and I'm going to widen back out here. Just like that, and we'll let it sit for a couple minutes, and then we're going to pull it off. And the table that I'm using here is actually from the 70s or probably before maybe, and so it's a very thick wood, and actually is very good at dissipating heat. So I don't let it cool down really long before I take it off of here. I just I probably let it get down to into 300s or so, so that the solder is a little more solid, and then I pull it off. And I actually put it on the table because I don't like the parts being this hot this long. So. Current temperature is 419, so we'll wait for a minute or so and then we'll yank it off. Okay, so we're down into 350s now, so this is a good time probably to go ahead and pull it off. Let me go ahead and pull it off. And actually I had the griddle backwards, so I generally pull it off this direction. So let me reach across there and grab it. And I'm going to set it down here on the table, just like that. Push this back out of the way. So there is the board, and it's still very warm. Too warm for me to touch it. Let me see what temperature it is. Down to 141 already. So definitely the table cools it off nice and quickly. And there are some parts of the board that will remain hot for a little longer than others. This board doesn't have a lot of copper on it, but the ones that are copper filled take a lot longer to cool down. And then in a second here, I'll move it somewhere else on the table. 125. So I'll go ahead and move it somewhere else just to help get a cool area because that area is really warm. let's see. Yeah, see, that's easy. I can hold my hand on that one, so it's definitely going down. And maybe enough to touch. I just touched it, and it didn't seem too bad. So let me see. Yeah, it's 83 degrees. So some parts of it are still a little warm, but I can probably hold it. So let's see. The next step is to inspect everything very closely, and I inspect things a couple of times just because this is so very new, and I want to make sure everything works. And now I'll actually take a multimeter and go into resistance mode. So I know these are 270 ohms. I will put something here and something on the jumper right there, just to make sure that the chips are all soldered in properly. And I'll check out the chips to where they go, and I'm pretty detailed about making sure the board's okay. But let me look at it really quick here now, so I can find any jumps or anything, and point them out. No jumps on that one. I don't think it's a jump, but it's not perfectly aligned. I don't see it touching on the pin, so I think we're okay. I don't see any jumps really. Oh wait, did that jump right there? Alright, well maybe I see one that's I have to look at. I'll clean it up just to make sure. And I'll see if I can get this on camera or not. Let's see. Can you focus on this? No, it's not going to focus. But right here on this end, if you look down there, there's some things that are almost a jump, and I don't like that. So I will take solder wick, basically put a little solder on the end of the soldering iron, lay the solder wick on, and go down really tight and go the whole way across this, and that'll level out all that. Just to be good. I'm gonna get the other resistors and everything, make sure they're okay. Yeah, they all look good. They're all on there tight. Capacitors are on there tight. So yeah, well, good. This board's done. So we'll have to go in and we'll check it out and make sure it's all electrically safe before we assemble it any farther. But that's surface mounting. So I've decided that I'm going to go ahead and do one more board. And I'm not going to talk through it. You're going to see me put everything on. But then I'm going to get to the reflow oven. I've never used the reflow oven before, but while we were doing this, I put it together. It was really that easy. So I'm going to maybe try to reflow something, and you get to see it either fail or work on the first try. Okay, so what you see here is an old oven from our old kitchen that my wife graciously donated because we have another one. And I've never used this before to do reflow. However, I've mentioned before in the show about the reflow Leo thing that I have, and I hooked it up to this oven, and I did run it once, but nothing in it. So what I'm going to do is I'm going to go ahead and put this board in there, and we're going to let it run through its cycle and see how it comes out. Now the thing is, I won't be able to see what it's doing. It's easy because with the griddle you can see it, test temperature, things like that. So let me be very gentle with this board. as I put it into the oven. Just like that. And now we're going to push it in. Still a little warm for my test. And we're going to go ahead and run this. Well, maybe not. Alright, here we go. Profile. And the oven's on. So we'll see what it does. So as you can probably tell, let me see if I can show this to you. Still a little warm. But if you look at this, let me see what I'm showing you here. You can probably tell it got a little baked. So it wasn't an oven, but look how dark it got. So that's definitely way too much heat. And the profile that came with this reflio thing cannot be right. I don't know if the board's even any good anymore. I'll check it and see, but it's pretty well baked. It's solid again, so it may just be that the oven itself has that on top, the broil thing, which I had broil turned off, but the broil thing came on, so we'll have to check and see if maybe we can figure out how to get the broil to turn off and on. But that may be what it was. But otherwise, looking at it, let me look a little closer here. The solder joints on this thing look really nice. So it does a nice job at doing the soldering. It just burnt the board. It browned the board. So we'll have to figure that part of it out. But looking at the solder joints, it looks really nice. So I'll test it out and I'll let you know if it worked or didn't. Okay, as you could probably see, that video was made over a couple different time periods of me soldering and stuff like that. And as you can see, I'm currently using a griddle. So when I was researching this, I had found that some stuff online that said use a griddle because it's safer for the parts, because the parts can actually evacuate some of the heat a little bit better. But it did talk about heating it up slowly, and I basically go to 150 and the 250. And when it gets to 250, I go ahead and crank it up the whole way. So it does heat up slow. The reason for that is that the parts heat up too fast. They do what's called tombstoning, where one end will pop up and the other end will be down, and they don't get good connections, which is probably part of what I had with my first one, but also had some of the weird solder still in there. And the thing about I mentioned before about just a tiny bit of solder, I'm just now getting to the point where when I put chips on, I'm getting the right amount of solder. I tend to put too much solder on them just because it feels like it needs it when I'm putting it on. It's not that much there, but it doesn't take much. In fact, if you put too much, what happens is they bubble up together and you get jumps across them. And for the first 20 boards, I bet I had at least one jump. For the first couple, I had a lot more than one on the chips. And that's because the pins are so close. So what you have to do in that case, you take solder wick, a little bit of solder on the tip of a soldering iron, heat it up, and go very slow across it as you pull it up. And that tends to get off all that stuff and works really well. The first board that I made, the first board ever, I actually ruined the board because when I was trying to clean off the solder, which was the solder that I couldn't get the flow, I was going across with solder wick. The runs on the board stuck to the solder wick because they were so small and tiny. So I basically ruined one of the boards in that process. So again, it's been a huge learning curve for me, although it's getting much easier. Now, one of the things in there on the video that I was talking about is the reflow, or the reflow Leo, and that's something I got from Kickstarter. And you saw the oven sitting there, and that I have to drill a hole in the oven yet. I haven't used the oven, but I think the oven may work a little bit better because it keeps the heat on top. I used the griddle so the heat didn't stay on top, but I think for it to flow a little easier, I need to go ahead and close it in so the whole area is warm, and then just open the oven up and let it cool out in the open air, kind of like I do with the griddle when I turn the griddle off. So the other thing you would notice, and I didn't really show you so much in the video, was I have a heat gun there. And sometimes if something doesn't look it's flowing right, but it's really hot, I don't like keeping the chip hot for very long, I'll take that hot gun or the heat gun and turn it on and go across the top real quickly just to make sure that everything's flowing. And then I'll turn it off, and then I'll remove the board from the heat so the chip doesn't get too hot, because I'm trying to keep the chips within the right temperature range. And that's one of the things that the Reflow Leo thing does, is it has a sensor in the oven, which I need to drill a hole for yet, but it washes the temperature and knows what the safe range is. And you put a profile in saying heating up to this level first, stay here for a minute, then go on to this level, and then stay for a minute, or whatever the pattern is you want to use. You put that in there, and it'll follow the pattern, and that controls the right heat level and everything. So that's the whole idea of the Reflow Leo. So that's my next step, is to get into the Reflow Leo and get that stuff all working. So maybe I can get that past, do another video, but it's come a long way. It's actually very interesting because it does look very, very professional. My first few, what's funny is when it gets hot enough that it starts to flow, everything kind of lines up. So if you got a resistor on a crooked, it'll come straight. It might not come perfectly straight, but it'll come straight. But the parts are very, very tiny, as you know, if you could see in the video with parts I was picking up to put on there. But they are super, super tiny. In fact, the magnifying glasses that I'm wearing are definitely a requirement, because you can't see where things go without them. In fact, the chips, you can't tell if you got them upside down or not when you're putting them on, if you don't have those on. And you can also notice this little round thing on there. That is needed sometimes, especially if you're looking at the pins for jumps. That's what you got to use to see, because the pins are just so small on those chips and so close together. So it takes a really close inspection to be able to see if you have a jumper or not. Across those, you can test for it, obviously, and it's part of this is me testing them extensively. Whenever I get done with this, each board I go through with and use LEDs to test things. I have almost built up a little test kit now for testing those kind of boards, because they're so prone to have problems if you don't get them right. Now the last couple boards I've done have come out really good. Now I've even started developing some shields now. These are mainly the button shield. So I've been doing a lot with broadcast buttons, especially for like the control surface that I'm building. But I wanted something that was easier than building a whole box. I just wanted to be able to do something really quick and write code in Arduino to do something quick. So I've actually developed shields now that can do up to 8 buttons at a time on a shield. And basically it goes, so it'd go Arduino, Ethernet, and then this would go on top of it. And you just get a regular Arduino box and cut the holes out where you need it, and then you have your broadcast box. I have a few things I want to do with those type of shields that are really quick. One of them in here is, right now you see I have an iPad next to me here. Actually, there's a bag here. This is the bag that the stuff came in. But the iPad, and it controls my audio board. But sometimes it's a little hard to get around in. What I'd like to be able to have is a box here. So if I have to cough, which tonight, unfortunately, I've been having a coughing spell a few times, I would like to be able to hit a button here and mute myself. It's basically called a cough switch. But I could do that all with an Arduino. The other thing I'd like it to be able to do is we have an audio subgroup. So if Bob's on with me and we're running a video, I can mute us. I can do it on the iPad right now, but it's a little pain. You have to go through different things to get there. But I like to make it one button. It'd mute us so we could talk to each other while the video is running. Without you guys, us interrupting the video that we're running. So there's a couple of things like that I like to do in here, and I like to be able to do something quick with an Arduino. Grab an Arduino Uno, an Ethernet shield, and one of these boards, put a couple buttons on it the way I want, label them, and then write some code for it, upload it, stick it in a box, and have it sit here and not have to go through the whole. The broadcast buttons work great, but they're all I2C and they run cables between them, and that's just a lot of work just for a tiny 1 or 2 buttons on a box. That's why I created these other button shields. So anyways, those button shields are all using surface mount because the buttons are big enough that if you run 8 buttons, it pretty much uses the whole shield space. There's nowhere to put through whole resistors on there. So what I've done is taken surface mount and stuck it on the bottom. So I'm even starting to make shields now with surface mounts on it. Anything we do with, as far as a kit to sell to people, we're going to obviously use through hole because not everybody can solder or wants to solder surface mount. So we'll use through hole for any of our kits or things like that and those kind of shields. But now I'm starting to realize the benefits of the saved space. Plus on the surface mount, they're actually, some of them on the bottom of where the switches are actually located on top. So it's like you get two parts for the space of one when you use through hole stuff, because they can fit, places where instead of going through hole, they wouldn't be able to fit. It's very interesting. It's actually been very fun to learn. It's a little frustrating at first, but now that I've done it enough, I'm starting to catch on to it. So anyways, I thought it'd be interesting to show you that video. So before we go, we want to remind you again that we do normally record at 9 p.m. Eastern. We started like 20 minutes early this week, and I see we have people coming into the chat room now. Vintage Volts is in there, and let's see who else. Like Bob may even be in there. So Vintage Volts is in there. Sorry, Vintage Volts, we started a little bit early tonight. We're coming to the end, and starting to finish up here. Anyways, we normally do every Monday night at 9 p.m. We started like 20 minutes early this week, and then we included the video in there as well. So next week we'll be back at the 9 p.m. time. And this is episode 37, recorded on September 23rd, 2013. Oops. Too many things going on at once. You can view all the videos for TechZen TV at youtube.com/TechZenTV. We do have all of our shows in the playlist format, so you can just watch whatever show that you want out there. And if you want to tweet about us, at TechZenTV, #, let's make it, and facebook.com/TechZenTV. All right. That is it for this week. We'll see you all next Monday at 9 p.m. For show notes for this show, contacts, and more, go to the techzen.tv website, where you can get show notes for all of our shows. We love to hear from our viewers and listeners. We have an email, a Twitter, and a phone number where you can contact us for each show. For details, visit the techzen.tv website and get the show details. You can also make a video and upload it somewhere like YouTube or Vimeo, and then just send us a link. You never know, you may see your video in a future show. You can get all of our shows delivered automatically to your favorite device by going to your favorite podcast website like iTunes and subscribing. Each of our shows also has a YouTube channel you can subscribe to get regular updates. Our shows are also available on most internet radio networks like Stitcher and TuneIn Radio. You can also watch and listen to our shows on Xbox, TiVo, and Roku. You can even find us on your Zune.